right, so for this section today, we're going to get started talking a little bit about lean problem solving. For the first section, we're going to be going over kind of some of the background information, primarily to get a feel from the business standpoint, kind of what the real necessity is for why we need to be effective at problem solving. It's kind of something that sounds pretty intuitive, but there are a couple specific aspects of it that are actually pretty important, especially when it comes to some of the things we're going to be learning and trying to implement later on. So without any further ado, we'll go ahead and get started with that. And so really kind of like to start out with some of these modules by just asking the most basic question, why are we here? What are we doing? What's the whole kind of big picture purpose of this? And kind of as we discussed, the key interest here is, okay, how do we solve problems, especially in a lean organization? How do we do that? Kind of what's our aim? What are we looking to do? And so out of that, kind of similar to some of the other things we've seen, this is really an iterative process. So through these sections, this module, we're going to learn kind of what the framework is, how we solve problems, what goes into it, what we want to accomplish, what we want to get out of it. And then it's a cyclical deal, where we practice that, we come back, we review, we practice again, and that's really how we kind of build our skill set and get to a point where we can start training and coaching others, which is the ultimate goal of this whole program. So, moving past that, getting into, why do we actually want to solve problems? Kind of big picture sense, what are we really looking to do here? And so, kind of from the thinking perspective of it, where problem solving fits into the kind of the overall plan for how we want to implement and kind of support a lean transformation, when we look at kind of the steps that go into this, the first thing we've already talked about, hopefully you've been through, is the philosophy section, kind of understanding I guess the big picture thing of what lean is, what we're trying to facilitate here. And problem solving is kind of the first layer of building the structure on top of that. So we can't really put kind of any of those philosophical concepts into place unless we're good at being able to solve the problems that are going to arise when we try and make some of these transitions. Then beyond that, problem solving actually is kind of a fundamental floor for the technical tools and the management aspect of it, which are kind of the two modules that come later on. And really, when we can kind of build that entire structure, what we see is when we get to the end of it is now we've got everything in place where we can really meet our overall kind of high-level goals, which are going to be highest quality, lowest cost, shortest lead time, in a nutshell. So really, what we want to do with this too is we want to make a standard approach. So when we go into an organization and we're looking at setting this up, everyone kind of has their own method, their own way they like to go and do things. And what we really want to do is we want to try and standardize the way that we solve problems and that we think about the way we think about solving problems. And really, the reason we want to do that, there's a couple of them, is we want to try and develop a culture within the organization so that everyone, every minute, every day, you've heard that before, is really focused on trying to expose problems, use a common language for how we're solving them, which you're going to see is fundamentally important. And certainly once you get into practicing this on your own, you'll really see the benefit of that. And then the last thing is we've got a culture where people are learning. Again, that cycle of learning, learning, and practicing. So if we can get everybody on board where everyone's doing it the same way, it's really just going to help make it a lot easier to kind of permeate every kind of nook and cranny of the organization, which is really what we're talking about when we get into kind of the cultural transformation side of some of these things. So what we're going to be talking about in this module is an approach to problem solving that we like to call practical problem solving. And there's a couple kind of aspects to it. And the first kind of half of what goes into that really is taking kind of a large, big, vague problem and kind of putting it through a funnel really and breaking it down into the individual components of it, what goes into it, finding kind of what the real little nugget is in that problem, and really just trying to whittle it all the way down into a point of cause. And really, you'll see a little bit later, kind of one of the key ideas out of that is this notion of going and seeing, and you've heard that again from the philosophy module, but not just thinking and assuming that we know what the problem is, but actually doing some investigation and finding out for sure before we start trying to put a solution in place. And then the back half of it is really kind of the cause investigation. So kind of a root cause, a 5 why analysis is the term we'll use, and it's really just kind of shorthand for just a kind of a double check, and we'll get into that a little bit too, but finding really the root cause of why did this happen and why was it passed along, because if we can't get to that, then any solution we put into place really isn't going to be addressing what's actually going on. So kind of in the basic sense, that's the approach that we're going to be taking with this. So, kind of just to reiterate what the key points are here that we want to do is it's critical that we develop this skill before moving forward, because one, it helps maintain the foundation of what we're trying to do, and then two, also it's absolutely critical support for what we want to do later on in order to be effective and be successful, which is really what we're trying to do. So again, coming back, why problem solving again? We'll look at it this time from maybe the business objective side. So not necessarily just the philosophical from the lean transformation side of it, but the practical business application. And from that standpoint, problem solving really supports kind of our overall big picture business objectives. So you'll see those you'll recognize from the structure, and the first one being stability. And if we can have stable systems, it really helps us maintain short lead times. I mean, you can imagine if you've got issues and problems you can't solve, you've got instability and how long it takes to do things, it really makes it difficult to maintain the shortest lead time possible. The second one there, building in quality, ties in directly. We want to be able to maintain a very high level of quality. Problem solving is critical for that. And then the last one is being efficient with the use of our human resource, which again is our most valuable resource. Really is something that we can do that really drives the cost of our entire operation down. So problem solving, especially in the context of these three items, is utterly fundamental. So the first thing we're going to be looking at is stability and the effect problem solving has on that. So what we want to start with here really is kind of understanding how we go about maybe classifying the types of problems that we have. And the reason we want to do that is because if you look at any potential problem we could have, there's a couple of them listed out here: equipment failure, rework, part shortage, maybe someone didn't show up, absentee issues, a training, a design, anything like that. Essentially every issue we have we can break down in kind of four different categories. Man, material, method, and machine is just the 4 M's is an easy way to remember that. And taking it a step further, those 4 M's, just to kind of drive it home and clarify it, man issues would be anything related to training or attendance, turnover. The machine, obviously that one's a little bit straightforward as well. We don't want our equipment to break down, we want it to run right, we want them to make good parts. With the material, obviously we don't want to have shortages, we want to make sure we use the right parts when we're building, or we get the right material and information when we're working in our processes. And then the last one, method, is also important, and that's any of the procedures and processes, the way we go about doing what we do. And that's kind of the 4 kind of key areas that we like to classify any of the type of problems that come up. And so when we think about, okay, we've got these types of problems, we understand kind of where they're coming from, and it's important to understand where they come from because that kind of frames the context of the solution. Is this really a man problem? Is it really a machine problem? Because obviously if it was a man problem, we wouldn't want to try and buy a new machine for it, right? So in kind of the traditional sense, then moving a step further, when we think about, okay, how are we going to address these issues? How are we going to account for downtime and instability? Normally what we do, because it's relatively common and it's kind of the gut reaction, the normal reflex is, okay, if we've got some issues with, say, being able to ship or stability, well, let's build our inventory up. So we've always got what we need on hand no matter what happens. Rainy day planning. We could add more shifts or work overtime. We can't get enough done during the day, so we'll just work more hours to account for it, right? That's pretty common. We could add more equipment. Obviously, we can't get enough out on what we've got, so we need to expand, we need to grow, we need a new building. And then the last thing, and this unfortunately is more common than I think we would all like to admit, is this kind of notion of it's not my problem, right? So I don't own it, I don't have control over it, someone else deals with that, hey, my hands are tied, I can't be involved with that. But really, at the core, all of these different approaches to dealing with this is to just add capacity, to say we don't have enough, we need more, we need a bigger building, we need more machines, I need more people, we need more inventory. And I think when we boil all that down, really in the kind of the fundamental sense from a business perspective, is money. That's money that we're spending to cover up for the fact that we can't solve problems. So what we really want to do is we want to move to kind of a new way of thinking about that, and kind of the lean concepts thinking that we use here is something where we call it abnormality management. And what that really is kind of these 3 ideas. But the first one is we want to be able to expose our problems and bring them to the surface. Make them visual so we can see what's going wrong, when it's going wrong, where it's going wrong, so that we can do something about it. We want to find the real root cause. Again, going back to this notion of practical problem solving. We really want to understand what's happening, find out what the real cause is here, so that when we put a fix in place, we know we're going to actually solve the problem. And then the last one, I think, is probably, from my experience, I would be willing to say that's probably the most important. This notion of fixing problems one by one as kind of a incremental, stepwise process. Because in the real world, when we go out, it's nice to go through here in a presentation or in a case study and find a problem and solve it. But in the real world, everybody knows when you walk into your office in the morning, there's 100 problems. And you could spend all day chasing and putting out fires. So if we don't focus on fixing our problems, making sure we get one fixed before trying to do everything, we can get buried. So this idea of one at a time, narrowing it down, fixing it piece by piece, is how we make sure with lean thinking and in the lean concepts world that we're always making progress. And again, that speaks just to the key point. We can't do it all at once, so let's find the biggest piece and let's fix it before we move on to something else. So this is just kind of a quick little graphic to demonstrate the difference between kind of the traditional way of approaching accounting for our problems versus that lean concepts approach, that abnormality standpoint. So, for instance, we'll draw this up there and say, the top line is customer demand. And the green bar, in an ideal world, we have the capacity to meet customer demand. But what we find in actuality is on our first shift with the yellow bar, maybe we don't meet the customer demand. We're 60% of the way there. So what's the traditional response to that? Well, pretty standard would say, well, let's just add a second shift. Right? We don't have the capacity, we can't get it done, let's add more people, let's add more hours, now we're producing to customer demand, everything's good. Well, except for the fact that we added a second shift. So in the lean concepts thinking, the lean concepts world, what we really want to do with this is we want to work to eliminate those obstacles that are preventing us from reaching our ideal capacity. Right? We don't want to cover it up with more stuff, we want to find out what's wrong and fix it. And really what that means is efficiency through problem solving, kind of at the core of it. And this is where we kind of bring back how those man-material method machine, breaking down and kind of categorizing our types of problems. So we have that whole big gap right there that we're trying to identify. And what we really want to do is we want to understand out of that total gap, okay, well, what part of it is due to the man issues, or the method issues, material issues, machine issues, right? Start breaking that problem down. Then in this case, the man issues constituted the biggest piece, so let's solve that part first. Let's not try and solve the whole thing at once. Let's find the biggest piece, let's go after that, and then we'll move on to the next thing, right? One by one, iterative. So, kind of stepping back again, is just a highlight of why working towards maintaining good stability matters from a business standpoint. One, it's the foundation of the lean transformation, and it's the foundation really and truly of any successful lean organization. And two, we want to be able to reach 100% OA. You think back to the philosophy section, that concept of operational availability, right? Planned versus expected, or in this case, we want our actual production capability to match and be equal to what we could do in an ideal world, right? That means we're running at 100% efficiency, and we want to be able to stay there. So above and beyond those kind of two key ideas, there's also some other benefits that come with having a stable production, whether it's in an office or a hospital or a factory. And really, I like to kind of split them out into the ones that are measurable, that you can kind of see and touch, and the ones that are immeasurable, that you just kind of feel in terms of the way the culture is reflected. And the measurable ones, you can get a sense for improved customer satisfaction. Again, going back, OA is increased, better efficiency, cost reduction, all that great stuff. But the immeasurable ones, which again, I think in my experience from what I've seen, really have a much, much bigger impact when you're talking about being able to improve communication, being able to get people more engaged in solving problems instead of staying hands-off, working as a team. And then that last one, human development, being able to get our team members new skills, new confidence, so that they can take on and start managing these challenges that up until then maybe we'd never been able to address. So kind of the next thing we're going to take a look at in terms of why problem solving is important is we'll look at this notion of building in quality. How do we maintain high quality? What do we want to do with that? So I think from, going again for this kind of juxtaposition, when you think of the traditional sense of how we manage quality, and really for the definition of that, just making sure we don't ship a bad product out of the building. So say we'll set up just a sample work process here where you've got 3 different steps that go into making something. So at the end of it, when it comes off the line, we've got an inspection step. Someone looks at it, a quality inspector, makes sure that this is good. And they've got a couple different things. So say they find one that's bad, well, they could send it back, we could rework it, ship it out, or they can say maybe this can't be fixed, so we've just got to throw it away and make another one, right? So rework and scrap. Then if it's good, it gets passed through, we go ahead and we ship it out to the customer. So in this model, in kind of the traditional sense that we've all seen, worked with, worked in, we really only inspect the goods when they're finished. We don't actually check it as it's being made. We just look at it at the end to make sure it's right before it goes out the door. Kind of what comes out of that is we don't necessarily get feedback to the people that are making it. So they maybe necessarily don't even know about these errors and defects that they're generating because they never find out about it. Someone on the other side of the building just fixes it before it goes out the door. And then the last thing that comes out of this kind of traditional model is we do have all that extra cost, that hidden plant that's in there of rework and scrap and paying really to make more than we needed because we don't have good quality. So what we want to do is we want to move that to, again, a lean concepts thinking, a lean approach to how we manage our quality. And so we'll set up that same sample process, but in this instance, each step only ships a quality product. So they're checking their quality at each station. And if, for instance, something comes out of A that doesn't meet standard, when it gets to B, it's stopped, it's sent back, it's repaired there, right? We don't pass it all the way through. And so the result of that is when something does get to the end, when it's ready to ship, we know, because we've been checking quality the whole way, that everything that comes off the line is ready to ship, right? So we don't pass those defects, we fix them as they occur. Everybody along that process gets immediate quality feedback. So if you put a new person on the line and they make a mistake, they find out immediately. They don't find out after they did it 1,000 times. They find out right away, so they know how to fix it, they know how to do something, they know how to do it the right way. And then the last thing is we find those defects at the source. So say we do make a mistake, now we don't have to have somebody go back through 4,000 parts trying to fix them all. We found it right when it happened. We don't have to do all that extra rework. So that's actually pretty powerful if we can put something like that in place. But again, this is where, able to support that, good problem solving is really a must. So when we look at, okay, how do we actually do that? Talk about building quality in at each station and making sure that we don't pass defects. Well, it requires a few things. So the first thing, we got to make the problem visible. The operator or whoever is doing this step needs to be able to understand that a problem has occurred, right? So they got to be able to see that abnormality. Then they have to have a mechanism to call for help and say, I've got an issue, something is wrong, I need to know what to do about this. Beyond that, the response to that call has to be immediate, right? If it takes 4 hours for someone to come help with this, I think everyone knows what happens in that case. Either people will just stop calling for help, or they'll just shut everything down and we won't get anything done all day. And then the last thing is we want to have a quick way to implement the countermeasure. And that countermeasure, as we'll see a little bit later, is a byproduct. It's a solution that comes out of our problem solving process. So as you can see just from this example, this has to happen in a very short period of time to be effective at checking quality and building it into the process. And that problem solving and being proficient at it is critical for this. So, out of that, kind of the two things, and I like to hit on this a couple times, just as some catchphrases. What we really want to do when we build in quality is we want to prevent the defect from happening, right? And then if it does happen, we don't want to pass it along. We want to catch it and we want to fix it right there. And so to do that, these is just a couple tools. I like to throw it in here just to get some exposure to them. But the first one is something called an andon. And there can be human andons, there can be machine andons. In the case of the human one, here's a flag. The machine one is a light. But really all an andon does, it's just a word for signal, is it stops the process, especially if it's a machine one. It'll shut the machine down, right? We don't want it just running bad parts. If it's a human one, they stop what they're doing, they put the signal light up. And what it really means is there's a problem here right now. We need to get help here. There's an issue that needs to be addressed. And so what it is, functionally in terms of the lean understanding is that it's a tool for visual control, right? We just made our problem visible. If you're a supervisor or you're a manager, even if you're working in an office and someone on the other side of the office has an issue and there's some visual cue they can give, so for you as the supervisor, you can look over and see, oh, okay, there's a problem here. It's that much easier to go over and address it in a timely fashion. Get started solving the problem immediately. The other one is something called a Pokio, which I like. It's a funny name. But in terms of building in quality, it's just something that's something cheap, simple, easy, like a fixture, a jig, or maybe a template. Maybe if you're working in a hospital, something, say, if you're in a hospital pharmacy, something simple that helps to make sure that all the pills, the right number of pills end up in the bottle, right? But it's something that comes from the team members, so the experts that are doing the process that'll go, hey, you know what, if we could maybe put this button on the other side, it would make it a lot easier to not accidentally hit it, something simple like that. And really kind of I throw the go and see there at the end because that's where these types of ideas come up from. If you're actually watching and observing, you can see real quickly, oh, if we could just do something little right there, it might make a big difference. So that's kind of the concept of a poke-yoke. And in terms of building in quality, you end up using those a lot. So that's kind of why I throw it in there. So kind of now the last thing that we're going to get to is using our human resource more efficiently and how problem solving ties into that. And that's huge, huge, huge in terms of minimizing and reducing our cost. So kind of the big concept that we want to focus on when we start thinking about, okay, how do we maximize our human resource, is we want to make sure, number one, that we're separating human work, man's work, from a machine's work. So in this example right here where you've got one operator, one machine, you can see that the human side of it is they need to take a part out and then put a part in. Well, the second half there is the machine running. And so with one person, one machine, that person has to wait on the machine. And just waiting is not a very good use of the skills and capability that come along with human time and a human resource. So what we want to do when we talk about separating man from machine is how can we structure our processes and what we do, and this could be the same as waiting for a printer to print. It doesn't have to be something in an industrial factory setting, but how do we structure our process so that one person can maybe run several machines? So in the example here you see as it spans out, you have the operator, and now they unclamp and they reclamp the part, and when they hit start on the first machine, the second machine behind them just finished. They can go take the part out of that, hit start, turn around, and start the cycle. So now you have machines doing what machines do best, and you have people doing what people do best, and we really maximize our time and what we're getting out of our work. So I will just real quick kind of show an example of what this separating human and machines work. Oh, go back there. What that looks like in real time. And Jidoka is another term we'll talk about a little bit later on. So in this case, what you can see is before the operator is going and he's working on one of these units, and what he's about to do right now is fire up the unit, sit there, start it, and he's got a little stopwatch that he's using. So he's actually starting the unit and then standing there with a stopwatch and just waiting. And so we'll see him, and it looks like he's getting ready to get started with that right now. And in real life, he ends up, in this particular case from this example, the operator actually ends up waiting about an hour, but this video isn't quite that long, so we'll skip ahead towards the end here in a second. So there we go, and this was shot in real time. So that individual right there had been sitting for about 45 minutes, doing nothing but watching his stopwatch. So there you go. 2 minutes of actual work, 45 minutes of watching a stopwatch. And without going and seeing, no one in this particular facility had any idea that this was occurring, except for the expert, that team member, that operator. He knew, but no one else was aware because no one had gone to see. So that's really the power. When you hear me say go and see, this is what comes out of it. So what we changed right here is we introduced a computer system that could do the timing for him. So what you saw him do right there, I'm sorry I was talking over it, is he set it up and then he left. Now he could go do other work. He could troubleshoot units, he could go work someplace else in the facility, he could go get some other things done, and then he knows to come back when it's done. And there you go. We took that process went from 47 minutes to 3 minutes by just being able to separate human work from machine work, and that is not uncommon. So this is the concept of andon, right? Stop and notify of an abnormality. So before, when there was no notification, that particular unit just had a problem and shut down. Can you tell? Don't feel bad if you can't. No one else working there could either. And in that case, you know, if they didn't know there was a problem, maybe they don't find it out. In this one, it took them 7 hours. So that was 7 hours that unit could have been running and testing to get out to the customer that just sat there because no one knew there was an issue. So what we do, that concept of andon, let's notify people when we got a problem so we can respond and fix it quick. We'll see right here. So there we go. You see the light flashing? Chamber faulted, the light comes on. Now the operator knows right away, here he comes, that there was an issue with that unit. He can fix it right now. It doesn't need to sit there for 7 days. Customer gets that unit that much faster. Process is that much more stable. No one has to wait around and just double checking everything. We just get notified when there's an issue. So that's really kind of the power that comes from that. And I like showing this real example because a lot of the stuff we talk about seems kind of abstract, but this is what happens when you apply it in real life. It makes a big difference. So, kind of then, obviously why it matters. Hopefully, some of this stuff, is a little self-evident. That last example, you save an hour of time for every unit you make. That ends up being a big deal. But those two things put together, this idea of building in quality and more effective use of resource, really the key focus is that it really drives us back to being able to build the highest quality with the lowest cost, the most, and importantly also, not necessarily most importantly, but do it in the shortest amount of time. Those three things are critical to being competitive. So, kind of the last thing we'll hit on here really is why problem solving in the lean concepts world, right? We can see the business side. Obviously, there's a lot of potential there for some real great savings. Outside of kind of supporting philosophy and some of the other things, we'll find out as we get into some of the tools, some of the management stuff, that a lot of this stuff comes back to this idea of visual control, like the andon, being able to see status at a glance, stop and notify, visual management of what we're doing. And so if the goal of a lot of these things is to make problems visible so that we can see, then this problem-solving approach is the way that we actually eliminate those problems. And we've run into it a lot where you can put in a lot of great tools, a lot of great lean tools, efficiency stuff, and notification, and all this wonderful stuff, but if you're not effective at actually solving the problems that it brings to the surface, you don't go anywhere, people get frustrated, and you don't have a lot of success with the initiatives. So this back half side of it, this problem-solving side of it, is absolutely critical. Cannot overstate it. And so, I throw this in here too. I like to talk about this because anytime you're going in and you're talking about doing something different, especially something like problem solving, again, I'll throw it back where everyone kind of has their own unique way they like to go about it, you run into a lot of cultural issues, and I throw these up here because these are 3 examples that I get all the time, everywhere you go. That not my responsibility, out of my hands, I got too many fires, too much to do. I can't sit here and do this and focus on this. I got to deal with all this stuff all day long. And really what we do with the lean concepts, with this lean problem solving approach, is that we kind of systematically address these things to kind of break through them and move past them. And not by just telling people, but by giving people the tools and the skills and the support to do this on their own, so they actually see that this works, that this does address this. And we don't make the transition to a new method because it's forced, but people come because they see that it works and it actually helps them be more effective at their job. So in the case of it not being my responsibility, kind of one of the key things that we get to with problem solving is, well, how do we figure out whose responsibility it is, and then how do we make sure we get the problem in front of the person that has the ability to deal with it? For just the example of I can't control what they do. Well, one of the things we'll get to is how do we build consensus? How do we work with individual experts? How do we get people engaged that have the scope of control and the role and responsibility to do the things that are beyond our capability to do directly? If it's someone in another department or another building or another area, how do we build those coalitions effectively and then be able to manage it and follow through with it? And then the last one is my favorite, the too many fires. If we go back to this idea of one by one problem solving, break it down, find something manageable, solve it one at a time, what we actually see in the real world, again going back, is you never run out of fires, but eventually it becomes a 1-alarm blaze instead of a 5-alarm blaze. And that, I think, is really where people get the most excited, really get the best sensation that this is working, when they actually can see that instead of running around all day trying to deal with just side effects and consequences, they really start making some headwind against these kind of issues that are repeatable, that happen all the time. They actually start seeing things go away and progress being made, and that's a wonderful thing. So the last thing I'm going to hit on with this, and I put this in here because this is something that I've learned just from experiences. When you talk about problem solving, when you look at, okay, here's the problem, there's the solution, there's a ton of ways to actually get there, right? And that's what we talked about. We want to try and standardize it. Well, we don't want to put the emphasis on the going through the motion and the steps. The emphasis should always be on the thinking. So what we want to be able to do with this is that as long as people are thinking about it right and we're thinking through it consistently, we want to make sure that we're giving people enough flexibility to be creative and to use their talents and skills to kind of work within this framework to be effective problem solvers. And then the other two things I throw in there too, because this is something that people run into right off the bat, especially when you're learning something new. It can be discouraging if you feel like you didn't do well enough at it. So I throw in there specifically, don't be discouraged by feedback, because that goes back to this idea of learning and doing, right? The practice. So when you go and you do it, the feedback you get, the constructive criticism you're going to get, is just to help make it better, and to not say that people aren't being effective at what they're trying to do. And then the last thing I put down at the bottom, when we actually get into solving real problems, and especially in the real world with big problems, it can be very difficult, and there's a lot of rabbit holes and cans of worms, and you can end up in left field and right field. And so I always like to reinforce for the people I'm working with that if you have to make a change of course in how you're solving a problem, say you thought the answer was going to be over here, you get there and realize it's not a bad thing that we checked that and we were wrong. It's really an opportunity to make sure that every time we got to change direction or go a different route, it's an opportunity we had to confirm that we were thinking about this the right way. And the fact that we found out we weren't and changed is a positive thing, because in the past we might have stayed down that route, put in a bad solution, and then been frustrated why we spent all this time and money and couldn't actually make the problem go away. And if that sounds familiar, it's because it happens to everybody. So that's kind of the end of section 1. When we get into the section 2, we'll discuss some of the other things a little bit further, kind of some of the specifics of the actual problem-solving methodology. And as always, feel free to direct any questions you got on the website, and we'll take care of them then. Thank you.